My question says, consider the function f of x, which is equal to x cubed minus 3x squared plus 4. Decide whether the stationary points are local maxima, local minima, or neither. Note the derivative is f dashed of x, which is 3x squared minus 6x, which is 3x times x minus 2. Okay, so stationary points are places where the derivative is 0, and I can figure that out by making this 0, and it's been helpfully factorized for me already, so I'm going to know that it's 0 and 2. And maxima and minima, well, a maximum is at the top of something. It means it's increasing on one side and decreasing on the other, and a minimum is decreasing leading up to it and then increasing after it. So what I need to know is where it's 0 to get the stationary points, and where it's increasing and decreasing in order to know whether they're local maximum or minima. Okay, so to get stationary points, I need to solve this. F dashed x equals 0, which means that 3x times x minus 2 has to be 0, which means that x has to be 0 or x has to be 2. Okay. So I need to decide whether the point on the graph with x coordinate 0 and the point on the graph with x coordinate 2, whether they're local maxima or minima, and that'll be done by deciding whether they're increasing or decreasing on either side. And I can decide if it's increasing or decreasing if the derivative is positive or negative. So I'm going to draw a diagram that tells me the sign, the plus or minus of the derivative. Sign diagram for f dash x. So these are the possibilities for what x could be. And 0 and 2, we already know that it's 0 for both of these. And here I'm going to say whether it's positive or negative. So it's going to be positive or negative here. It can't be 0 in any of these places, and it can't be positive and negative here, or it would have to cross 0 in there. So it's going to be all positive, all negative there, all positive, all negative there, all positive, all negative there. So all I have to do is test one point in the derivative to see whether it's positive or negative in that bit. Okay, so when x equals minus 1, f dashed of minus 1 is 3 times minus 1 times minus 1 minus 2. That's negative, that's negative. Positive times negative would be positive. So that's a plus there. When x equals 1, which is between these two, f dashed of 1 is 3 times 1 times 1 minus 2. That's positive, that's negative. So the whole thing's going to be negative. And when x equals 3, f dashed of 3 is 3 times 3 times 3 minus 2, which is going to be positive. Okay, so that means that the derivative is positive here, negative here, and positive here, which means the function's increasing here, decreasing here, and increasing here. So a very rough sketch. That's 0 and that's 2. My function's going up and then down and then up. Now, it's not that actual shape. I mean, it certainly doesn't have a kink in it, but that's enough to tell me that there is a local maximum here at 0 because it's going up and then down, and a local minimum here at 2, which is going down and then up. So one of them's a local maximum, the other one's a local minimum. So I guess I should round it out with a summary. So local max at x equals 2, and a local minimum at, local max at x equals 0, and a local minimum at x equals 2.